Hi class, so in this video I'm going to review with you the third quarter review sheet for the exam on Wednesday. Remember, there's approximately 25 multiple choice questions plus one short essay question. And if you know how to do this review sheet, you're going to be in really good shape. So the first question is, what are the characteristics of metals, nonmetals, and metalloids? As we learned from the Properties of Elements lab, the metals are shiny, they're malleable, they conduct heat and electricity well, and they react more readily, in our case with hydrochloric acid and copper 2 chloride. On the other hand, nonmetals are dull, they're brittle, they do not conduct electricity or heat very well, and they do not react with hydrochloric acid or copper 2 chloride. Now, metalloids is a mix of the two. So you could pick one from the metal category and the rest from the non-metal category, but it's the mix of non-metal and metal characteristics. Pick shiny from the metals, and we could pick brittle from the non-metals, and then the last two from the metals. It could be any combination, but not contradictory. The next question says, label the metals, nonmetals, and metalloids in the blank periodic table below. So first you have to make sure you include the stair step, and then you know that anything that sits on the step or near the step is going to be your metalloid or semi-metal category. Then anything in the top right hand corner of the periodic table are the nonmetals, and everything else on the periodic table except for the noble gases, all of these elements on the periodic table are metals. In the next question, label the halogens, alkali metals, alkali earth metals, noble gases, transition metals, and intertransition metals in the blank periodic table below. So, firstly, the halogens I'll label in black. The halogens are group 7A or 17 on the periodic table. The alkali metals I'll label in red, and those are the first group, group 1 or 1A. In blue, I'll label the alkali earth metals. That's the second group. In green, I'll label the noble gases. I will label the transition metals in gray, and I'll kind of crosshatch them here. But it's this middle area between the representative elements. The representative elements are these ones and those ones, right? Group 1 and 2, A, and group 3A through 8A. Those are the representative elements. And in green again, I will label the intertransition metals, and that's at the bottom here. And I'll crosshatch them. Remember that the rows on the periodic tables are called periods, and the vertical columns on the periodic table are called groups or families. The next question says, how did Mendeleev predict the periodic properties of elements that had not yet been discovered? So firstly, he knew some chemical and physical properties from other scientists from published information. So this is what he knew. And then he organized the elements on the periodic table according to those chemical and physical properties. Then he noticed that there were gaps in the periodic table, and for elements that were found later. So he could predict, based on the elements around the gaps, what those elements will look like. The next question says, write the number of valence electrons above each element on the representative elements in the blank periodic table. Remember, the representative elements are these ones on the periodic table. And it's a very simple order, as you probably already know. It's 1 valence electron for group 1A, 2 for 2A, 3 for 3A, 4 for 4A, 5 for 5A, 6 for 6A, 7 for 7A, and 8 for 8A. Remember that elements in the first group are like lithium, you're going to have 1 dot. For elements like magnesium, we're going to have 2 dots. For elements like aluminum in the third group, it's going to have 3 dots. For elements like carbon in the fourth group, it's going to have 4 dots. For elements like in the fifth group, like nitrogen, it's going to have 5 dots and one of them is going to be paired. For elements in the sixth group, like oxygen, 2 of them are going to be paired. For elements like chlorine, all of them are going to be paired except 1. And in the eighth group, like neon, they are stable, so that's why they're called noble gases. They're too good for the other elements. Now the exception to this is helium. Helium only goes up to the duet rule, 2 electrons. Question number 6 says, what is electronegativity? How do differences in electronegativity cause different bonds? So electronegativity is the attraction of atoms for valence electrons. So if we have a periodic table, the most electronegative element is F on the periodic table. And the least electronegative element on the periodic table is francium. So that means fluorine wants to get electrons from other atoms, and francium wants to give up its electrons to other atoms. So how do differences in electronegativity cause different bonds? So if they have very similar electronegativities, and they're both nonmetals, it will be a nonpolar covalent bond. If they have close electronegativities, it'll be polar covalent. And if they have very dissimilar electronegativities, they will have ionic bonds. If there's a metal and a nonmetal together. Number 7, when comparing the bond between NO, OO, and CO, which bond is the most polar and why? So if we bring up a periodic table here, we see that if it's OO together, they have the same electronegativities. So that's going to be a nonpolar covalent bond. So that means it has to be CO or NO for the most polar. Now notice that N and O are right next to each other on the periodic table, so that means they're going to have very small electronegativity differences. Well, CO is going to be having the bigger electronegativity differences because they're further apart. So CO is going to have the most polar bond, because there's the largest electronegativity differences. I can know that even though I don't have an electronegativity table, because they are furthest apart on the periodic table. Question number 8 says, explain how VSEPR leads to knowledge of the three-dimensional structure of molecules. So first you have to know what VSEPR stands for. VSEPR stands for valence, shell, electron, pair, repulsion theory. the electron pairs that are present around the atoms in compounds are repelling each other. And when they repel each other, they push away as far as possible from each other and create the largest angles possible. Lone pairs, single bonds, and double bonds and triple bonds can act as effective pairs to create three-dimensional structure. In addition, lone pairs are causing extra repulsions on other lone pairs because they are more negative. So this question has several parts. You have to be able to define what VSEPR stands for, what the electron pairs are doing, what are effective pairs, and what are lone pairs. So essentially 4 parts to the answer. Question 9 says, what does it mean when a molecule is polar and when it's nonpolar? A molecule that is polar is asymmetric, and a molecule that is nonpolar is symmetric. So a molecule like NH3, which has a lone pair on it, is going to be polar because when it's divided this way in three-dimensional space, you see that this side is uneven compared to this side. The bottom side has hydrogens on it, and the top side has a lone pair. And nonpolar molecules like oxygen can be divided and they're the same on both sides. And what's the implications of this? Well, this is question number 10. What does like dissolve like mean? So when things are of the same polarity, they dissolve in each other. What this means is that polar substances dissolve in other polar substances. Like ammonia dissolves in water. This also means that nonpolar substances dissolve in nonpolar substances. So for example, iodine would dissolve in oil. So again, please make sure you understand these answers and write them down and be prepared to do really well on the exam tomorrow. Good luck. Bye.